So again, in a little more abstract sense, suppose you're at a carnival and a hot dog eating contest, and Fred ate 8 hot dogs, and Bob ate 12 hot dogs, and June ate 20 hot dogs, and Bill also was only able to eat 8 hot dogs. Well, you'd see that June won this contest, but this this abstract system is exhibiting functional behavior, because for any given starting condition, each of these individual components has exactly one outcome. Even though Bill and Fred have the same one, this still would be considered functional. On the other hand, suppose I look at this abstract situation where after they have their hot dog eating contest, they exchange phone numbers, and Fred has this phone number, Bob has this phone number, June has this phone number as her home phone, but she also has this phone number as her cell phone, and Bill lives with Fred and they share a landline. So if this sort of situation occurred, this would so our names here, we could call this our names, and our numbers for phone numbers. We would say here that names are not, or actually, let me restate that. Numbers are not a function of names, even though there are relationships. And the reason that that's the case is because we have both Fred and Bill have a non-unique number. And of course up here, if we label this as names and eaten, maybe number of hot dogs eaten, up here the eaten is a function of names. So carrying that idea through with our equation up here, in this equation, the equation is 16t squared equals d. Here, when we put in a value for t, we get only one value out for d. So d, let's write it as a small d since I wrote it as a small d there. D here is a function of t. And down here, speed, for the same idea, speed is a function of time in these relationships. So suppose I give you a set of ordered pairs, 0, 0, 1, 2, 2, 4, and 3, 9. And I might ask the question, is this set of ordered pairs a function or more betterly expressed, is in this set of ordered pairs, in each of these situations, is the second of the pair a function of the first? And you would say yes here, because for any given value, there is only one y value. For any given x value, there is only one y value. So 0, 1, 2, and 3, each of those produce one and only one y value. It's like the Highlander. There can only be one. On the other hand, let's look at this set. Suppose I had 0, 0, 1, 1, 4, 2, and 1, minus 1. In this case, this set is not exhibiting functional behavior with respect to the second term. In other words, the y value is not a function of the x value in these pairs, because although these first three have unique y values, the fourth one here, 1, for the x value gives us minus 1 for the y value. But over here we saw, or actually here, we saw that for the x value of 1, we got a y value of 1. So we have, for the same x value, we have two y values. And that means that this is not behaving as a function. And you can think of this in terms of your calculator. Your calculator, the buttons on your calculator are set up so that they work function. The routines on your calculator are functional. If you take your calculator and you do something like you do the square term on your calculator, you're only going to get one answer. You don't get multiple answers. And I'm going to end there.